In the last class, we have discussed up till here. So, we saw how to draw the projection when the axis of the solid is parallel to one plane, right? So it is parallel to one plane. So either it is parallel to the, so in this case, so it is parallel to the VP, all right? So in this case, it is parallel to the HP, okay? So in this case again, it's lying on the HP, so the axis is parallel to the VP, right? So we have discussed various solids whose axes are parallel to one of the planes and it may be inclined to the other plane. So today what we are going to discuss is when the axis is inclined to both of the planes. So how to draw that, right? So here is a question here: a hexagonal prism base 40 side. So hexagonal prism base 40 side. So it is, no, this is done. Yeah. So a pentagonal prism. So this is done already. So this is the hexagonal prism, and through here we have the hole. And we, yeah, I mean, in the last class we observed that this hole. So this is the circumference which we will observe from the top view. Right. So entire circumference of the hole we will observe from the top view. The circumference at the bottom of the opening. Alright. So that part we will observe certain part of that opening from right through the hole, right through the hole we will observe certain part directly. Alright, so we will see this part directly and the rest will be in dotted line because those we will not see directly, and we have to mention that those are present there. Alright, the hole is present there. So we saw how to get that. Anyway, we will again see that because this is the first step of what we are going to do next. So a pentagonal prism. So pentagonal prism. So the face is of this manner. Pentagon is a prism is resting on one of the corners of its base. One of the corner of its base. So one of the corner of its base on the HP. The longer edge containing the corner is inclined at 45 degree to the HP. Alright. And the axis of the prism is making an angle of 30 degree to the VP. So if we see this, alright, so I will just so first of all the prism itself is making an angle of 45 degree to the HP, alright, and then the axis itself, alright, so the axis is making 30 degree to the VP. So as in case of the lines, as in case of projection of lines that we did, so we have this plane, so 45 degree to the HP, it is inclined at 45 degree to the HP and 30 degree to the VP. Okay, so the end point is at this. So this is the axis of the pentagonal prism, right? So how to go about that? So first of all, we will consider the prism to be, definitely it is just standing in front of the, so we have the prism here, so it is in this manner. So this is the face and it is standing right in front of the VP. So this is VP and this is HP. Okay, so we draw the prism, the edge of the prism, so we get the top view. Alright, we get the top view. So we draw the top view first. So this is step 1. Then from here, from various points, we drop the vertical projectors up. Alright, so from the axis we project up. Alright, so axis is important in this case. So axis we have to mark. Alright, the centroid or the center of the pentagonal prism. Alright, so we project it up, and we get the top view as well as the front view in this case. So the prism is just standing in front of the HP and the VP. So the next step is what we do. We rotate the prism 245 to the HP. Alright, it is given here. It is inclined at 45 to the HP. So that is the next step. So we incline the prism at 45 to the HP. So initially the prism was standing like this. So now it is inclined at an angle of 45 So this figure we have to rotate it to 45 Alright. So you can draw a 45 line. You can take this measurement and then you mark a arc here. Alright, so you take these measurements. Alright, you can mark arcs here. Alright, and then you can draw the projections. And this is dash dot dash dot dash. So this is the axis. Okay, that is the axis. So now from here what we do, we have to draw the top view in this position. So what will be the top view? So when we will see from the top, what will we see? So in that case, what we will do, we will first here, we will drop horizontal projectors. Alright. So from here we will drop horizontal projectors. So from this point as well, we will drop horizontal projectors. So from this point as well, we will drop horizontal projectors, and this point as well. We will drop. Alright, so this is here. So from here we will drop projectors like this vertically down. From here we will drop projectors vertically down. Again in this manner we will drop the projectors. Alright, so that is the third. This is the first step. So step 1. This is the second step. So step 2. And this is the third step. Step 3. And this is the fourth step. Step 4. So we drop the vertical projectors down and horizontal projectors to the right. So we have the projectors here. Alright. So now we have to make the face of the prism. So here you see, so we have, so when it will be inclined, so we have this face here. So 5 is projected down here. So we see 5 here and 5 here, the projection here. So this is one point of projection. So similarly 1 dash here, it is projected to this point. So 1 here and 1 here. Alright. Then let us see the 3 dash. Okay, so 3 dash is projected to this point. Alright, so this is 3 dash. So that is actually, it will be 3 dash. So 3 dash is projected to this point. Okay, then 4 dash is projected to this point. 2 dash, so this is 4 here, it is projected to this point. 4 dash is projected to this point. 2 dash is projected to this point. So 2 is projected to this point. Okay, so now we have the face. So this face, when it is rotated at 45 degrees, so how it will look from top. So we have this face here. So that is this face, this face, that is the top face. Okay, now let us see the end face. So here A dash is projected up to A1 here, so this is A. Then E dash is projected up to E here, so this is E. Alright, then D dash is projected to this point D. Alright, so this is D here. Similarly, B dash is projected to this point, so we have B here, so it is projected to this point. Alright, and similarly C dash is projected to this point, so this is C. Now thing is that if you observe, if you see from top, so you will see this edge definitely, you will see this edge definitely, and you will see this edge, but you will not see these two edges when you see from top, so this will be hidden here out of sight. Right, so this edge will be thick lines, this edge will be thick lines, and this edge will be thick lines. Okay, and this will be dotted, so up to C, sorry. So up to C it will be dotted line. Okay, then what about this edge E dash 5 dash, so that you will see from top definitely, so this you will see from top, so this is the edge that you will see from top. Similarly, this also you will see from top. Alright, and similarly this edge also you will see from top. So this will be A1 and A dash 1 dash. So A dash 1 dash. This is A dash 1 dash. Alright, and B dash 2 dash also you will see. So B dash 2 dash. This is B dash 2 dash. Okay, so this is the top view. This is the top view when the hexagonal pentagonal prism, it is rotated at 45 degree to the HP, 45 degree to the HP, and the axis is still parallel to the, it is still parallel to the VP. Okay, now we have to rotate it, so we will rotate it in such a manner that it fulfills this, so the axis of the prism makes an angle of 30 degree to the VP. So if you remember, if you remember when we did projections of line, so if this is 45 degree and if this is 30 degree, so this is the line. Okay, so this is the line. So when we rotated, so the projection moved on a line which is parallel to the XY line. Right, the projection of this point, it always remained at same elevation because this angle is fixed. Alright, similarly, when we suppose we consider this at 30 degree here, alright, So this projection it moved. So when we rotated it up, right, or in this manner, so this projection also it moved on the HP in the straight line which is parallel to XY. All right. So that particular concept we will use to draw the axis of the prism first. Alright. Now axis of the prism is actually inclined at 30 degree to the VP. So the top view will not be. So the top view, so here, so this is what it is making. So this is the angle. So this beta angle, alright. So the beta angle we have to find out. Alright. If you remember when we made the drawing for the uh, line which is equally, which is inclined to both horizontal plane and the vertical plane. Alright. So I think this step is clear. So this from here we have this figure here. So we have obtained this. Okay, so this is the top view. So now what we do, we will choose a point, any arbitrary point P. Okay, so we'll choose a point P. So this is the point P. Alright. Then from here, what we will do, so either you take this one or you from here also if you take this one, same thing. So uh, from here what we will do, so from here on we will draw a line which is inclined at 30 degree. Okay, so this is the point P. So now we have to obtain the trace of the line. So we have considered the line to be at 30 degree. So now we will rotate it up. So when we will rotate it up, it will move on this point. So we will obtain the beta angle. Alright, so this is the line. So this is the angle. Alright, which is inclined at 45 degree to the VP as well. Alright, so 45 degree we have already rotated. Sorry, not this one will not be 45 degree. That will not be 45 degree. So if we rotate it here in this manner and we draw this line, so that will be 45 degree here and this will be alpha. Alright, so we have either rotated from this point to this point or from this point to this point, whatever way we did. Okay, so here what we do, we have marked the point P. So then we will take the axis of the actual prism, so 70 mm. Alright, so that this is 70 mm. That is, so it is inclined at 30. So we will take, the axis is inclined at 30. So we will take 70 mm and we will mark an arc here at 70 mm. So this to this is 70 mm, the axis of the prism. And at this point, we will draw the loci of the trace of the projection of the O dash point. Okay, so the O dash point, when we will rotate by this 45 degree now, alright, so we have already considered 30 degree here, so we have to rotate it by 45 degree, so it will move along this direction. So when we will rotate it by 45 degree, we will get this distance. So because this distance is already rotated by 45 degree, alright, so this distance we will get. So what we will do now, we will take this as the radius now and we will mark an arc here. Alright, taking this as the center. So arc will be in this one. Alright, we will mark an arc here. So this is the inclination beta of this projection. Okay, so just clear your mind and try to recollect whatever you have learned in your uh, projection of lines. So that concept we are applying here. So we are now considering only the axis. Now remember, this axis is already rotated by 45 degree. So it is already, this is a projection of the axis of 70 mm length rotated by 45 degree. So this is already cos of 45 degree, this length. So it is rotated, already rotated 45 degree. Okay, so now what we are doing is we are rotating it in such a manner such that the axis is rotated by 30 degree. So it is, the axis is now at 45 degree to the HP and 30 degree to the VP. So it is satisfying both of this condition. Okay, so the first step is to choose a point P, alright, such that it is a little bit below 70 mm, alright. So because you have to draw the prism over this axis, okay, over this axis you have to draw the prism, so that you have to keep in mind. So you take a little bit further distance away, so at that point you mark the point P. From there at 30 degree angle, 30 degree angle, alright, you mark a distance of, from the P you mark a distance of 70 mm, which is the axis. So this 70 mm is marked. Now we have to rotate it to the point which is also satisfying 45 degree to the VP. So to do that, we draw this line which is parallel to XY. Okay, we draw this line which is parallel to XY. Then what we do, we take this length as the radius, because this is already rotated by 45 degree. So we take this length as radius. Taking P as the center, we mark an arc. So this is the angle of inclination of the top view. So this will be the angle of inclination of the top view. So we take the point P and we mark the distance 70 mm and we draw the line parallel to XY here. Because the point P, when it is rotated, so it will move along this point. The point O, sorry, the point O1, the point O1, when it will be rotated, it will move along this line, right? So here now we mark this O1. Okay. So about this, you have to now reconstruct this particular figure. Okay, so you have to reconstruct this particular figure. Okay, so that is the top view. So how to do that? You can, so you take this distance, all right. So you drop one parallel line. You take this distance. You drop one parallel line. Okay. You take this distance. You drop one parallel line. Okay. And then you, from point O, you take this arc. Take this arc. All right. And you mark the points. All right. And you reconstruct this figure. Right. So this figure you have to rotate it in this manner. Okay, so from O you can measure this points here, so this points here, this point here, all right. Then this projector here, all right. So this projector here, okay. So you have to reconstruct this figure here. So that is the thing. So here you note, so 3 1 is moved up to this point. So this is 3 1. Okay, so 2 1, so this is 2 1 is moved up to this point 2 1. So 4 1 is moved up to this point 4 1 here. Okay, 5 1 is here and 1 1 is here. So this face, so this face is basically this face over here. So it is rotated by 30 degree. And this face, so E1 is here. So E1 is here, A1 is here, D1 is here, alright, and B1 is here, and similarly C1 is here. So you can see these are the dotted lines. So these are the dotted lines, which these are the edges which we will not see. Alright, so here and here are the edges which we will not see. So these are the edges we will not see. So those are the dotted lines here. Alright, and this face over here, it has rotated by, so E1 5 1 1 1 A1. Alright, so this face, it is rotated like this, in this manner. Okay, so that is the face there. Right, so the bottom face, this is the bottom face here, and that will be in this manner. So the axis is basically rotated. So this P1O1 is now P1O1 here. Alright. So now what we do, once this construction is done, we again drop vertical projections up. Right, we again drop vertical projections up. Okay, so the lines may not be perfect, so we drop the vertical projections. From the various points. Okay, and similarly from here also, so to get the 3 1 point, so 3 dash is projected and we will get the intersection 3 1 point. 4 1 is projected and here from 4 we will get this 4 1. Okay, 5 1 is projected and from here we will get the 5. Alright, so similarly you will project the various points and ultimately you have to construct this front view. So this is the ultimate required front view. Okay, and this is the required top view. Basically this is the top view itself. So from this top view we have to rotate it in such a manner that it satisfies the condition. So it is the axis is now at 45 degree to the HP, 45 degree to the HP and 30 degree to the PP. So those two conditions has to be satisfied by the axis. So here this is alpha, this angle is alpha. Okay, so axis is, both the axis is now at 45 degree and at 30 degree here. Okay, so this is 30 degree. Now if you notice the second part, so here it is written, you can notice the second part, also draw the projection of the solid when the top view of the axis is inclined at 30 degree. So the top view, that is when the beta is already given, so it is 30 degree. Alright, here phi was given, so it is inclined at 30 degree to the VP. Here beta is already given. So in this case, so instead of going for all of this, you just need to draw it at 30 degree, 130 degree angle, alright, and then take this radius, alright, and then you mark the point, alright, and then you reconstruct this figure here, alright. So this is, so here you see the change here, right? This is the change. So here you see this is 30 degree, and here you see the axis is making 30 degree. Alright, and we have to find out the beta. So beta is a little bit higher than 30 degree, and here it is a little bit less. So you can see the change in the front view and the top view. So you can see it is rotating. So you notice this one, alright. So it is a little bit inclined at a higher angle. It is 30 degree, alright. So that is the difference. Right. Similarly, there will be change in the front view as well. All right. So the front view also will change. So same thing, same process. Here it is easier. You directly, since beta is already given, you directly mark the 30 degree line. You mark the point P1, O1, and you reconstruct this figure. Okay. So if you find difficulty in doing that, reconstructing this particular figure, so what you can do is you can also rotate it here itself. Alright, you can rotate it here itself. So if I rotate it by 30 degree, alright, so all the points will be rotated by 30 degree. Alright, so here also you can do the construction. So and then for at equal distance you can project that. Okay, at equal distance you can project that. So whatever ways you find it easier, you can do that. Okay, so that is the thing. So here also you can now, here suppose I construct this 30 degree line, so I will rotate the point O1 here. Then similarly in this axis, so all of this has to be rotated, so about all of these points. Alright, so 30 degree like this. Alright, so from there on you have to reconstruct the pentagon in this manner here. Okay, in this manner here. So you rotate this 30 degree, 30 degree. Alright, so you will get the rotation of this entire thing. Okay. So this is an important point you have to keep in mind. Okay. So when this kind of differences are given, so you have to make a note here. So the axis is making an angle 30 degree, and the projection of the solid when the top view of the axis is inclined, top view is inclined at 30 degree. Alright, and here the axis itself is 30 degree. Alright, so that difference you have to note. Alright, so the steps are already explained here, so you have to get the front view and the top view. So here it is 30 degree, it is top view, and this is front view. So draw the projections of a cone base 45 mm diameter. Alright, axis 50 mm long when it is resting on the ground on a point on its base circle with the axis making an angle 30 degree with the HP and 45 degree to the VP. Alright, the axis making an angle 30 degree with the VP, and its top view making an angle 45 degree with the VP. So same thing over here. Alright, so like here also we have explained. So first we start with the cone. Alright, so we assume that the cone is resting on the HP. So the cone is resting on the HP. So this is the first step. So the cone, it is resting on the HP. Alright, so if we see from the top, we see this one, and if we see from the front, we see this one. So we have to divide the circle into equal parts. So mark these points. Alright, so and get the projection of these points on top here. Alright, resting on the ground, when it is resting on the ground on a point on its base circle. Okay, so it is resting on the ground on the base circle here. Alright, and axis is making an angle 30° with the HP. So first let us consider this 30° with the HP. So what we have to do is we have to rotate this so that it is making an angle of 30° to the HP. So once you construct this, so all of these points have to be shifted here so that we can project projectors from there. Alright, so this once this is done, so step 1, step 2, step 3. So from here we drop the projectors down. So from here also you drop the projectors. From here also you drop the projectors. Alright, and from here you drop the projectors. So you get the top view of the base of the cone. Alright, so this is the top view of the base of the cone. So here you can see this is dotted. Okay, so this is dotted. So that means you can from when you see from top, alright, so you will see this cone, this part of the cone here, alright, but this bottom part will be hidden. Okay, so this is the surface of the cone that you will see. Okay, so this part you will not see. So this part of the cone you will see, the top part. Okay, the top part of the cone you will see. So that is what is the projections here done. Okay, so that is the projections. So now again, so the axis is making an angle of 30° with the HP. Alright, and 45° with the VP. So axis is making an angle 45°. So the next step is to again get a point, alright, and you drop a line which is 45°. So again here what we have to do, we have to take the length of the cone and we have to mark the length of the cone. Alright, so 45° at 45° with the VP. Then we have to draw the parallel line to the axis. Alright, and then taking this point as the center and this as the radius. So it is all, this is already rotated by 30° to the HP. So from here what we will do, we will mark a point 30°. P1O1. Alright, so this, so we will get the beta angle. So we will get a beta angle. Here also, here itself you can do that. So once you get the beta angle, alright, so here you can drop parallel to the beta angle and you can draw the, you can shift the points. Okay, you can shift the points and you can draw the cone here. So here itself also, here also you have to draw the cone in this manner. This will be the cone, the top view of the cone. So once you draw the top view of the cone, again from the points you have to drop vertical upwards, alright, and then from here horizontal rightwards, alright, and then you have to get the top view and the front view. Okay, so again here you see, so this is a point P. So from here it is marked 45°. So we obtain this point. So along this point you draw this line. parallel to xy. All right. Then you take this P1 O1 as radius. Again from P1 you mark this O1. Okay, so this is the angle of inclination of the top view, that is beta. Okay, so you get the, so you just rotate this view, so that is the top view itself, and from here again you have to drop projectors up, right? And from here you drop the projectors horizontally right, all right, and you get the front view. So you, this is the section of the solid or the cone that you will see, and here you see this is the dotted line, so that will be hidden. So here also you see, so this you will see, this edges you will see, and this over here, this is the dotted line, right? So that section you will not see, right? So you can see O1 is here, 4-1 is here, 10-1 is here, right? Similarly 1-1 is here, all right, and P1 is here, right? 7-1 is here. Okay, so that is the top view. Now if you again concentrate on the second part, so the second part says the axis making an angle 30 degree with the HP and its top view making an angle 45 degree. Alright, so top view is making an angle. So in this case, it is directly 45 degree. So this you have to rotate it by 45 degree. Alright, same as above what we have discussed. And then from here you drop the projectors and you get the front view. So a square prism has base 40 mm, side and height 65 mm. Alright, square prism. So it is basically a square and it is in this manner. Okay, so this length is given 65 mm, 65 mm, and this size it is given 40 mm. Okay, so in this manner, so this is 65 and this is 40, has an edge on its base on the HP. So the one of the edges on the HP and it is inclined at 30 degree to the VP. Axis has its axis inclined at 45 degree to the HP. Right, axis is inclined at 45 degrees. So it is 45 degrees. So if we consider the axis is 45 degree to the HP and has an edge on the of his base. So edge of his base on the HP. So it is here itself. Alright, and the axis and is inclined at 30 degree to the VP. Okay, this base is inclined at 30 degree to the VP. Right, so that means the entire thing is also inclined at 30 degree to the VP. So it is like this. So it is 45 degree from the HP and 30 degree to the VP. Alright, so what we do, first of all we start as the prism is standing right in front of the, so this is the square prism. Alright, so it is standing right in front of the VP. So that is what we are doing. So top view, we draw the top view first. So this is the top view. This is the top view. And the front view. And the front view. So first has its axis inclined at 45 degree to the HP. So we rotate this 45 degree. Right? So we rotate this 45 degree. Easier. So 45 degree. And then we project it down. Right? And we project it left. Right? So this is the top view. Okay, so this is what we do. So this edge over here will be hidden, all right, and all of the edges will be hidden behind the upper edges here. So this edge will get hidden behind this edge, so we will see only this edge on the top. So this is the top view. So step 1, step 2, step 3 at 45-degree rotated, axis is rotated at 45-degree to the HP. Alright, so and then step 4, right, you drop projectors down, 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 and you get this one. Then what we have to do, we have to rotate this such that it is making an angle 30 degree. So very easy. Right, from there you project up. Alright, and from here project left. Alright, and you get this projections here. Alright, so here, yeah, so here you see this edge is on the HP, edge of the base is on the HP. So this edge, so basically this dotted edge is on the HP, because we will not see that, we will not see from top, that edge will be hidden. So that is inclined at angle of 30 degree, and we get this front view. All right, now it may be rotated to the other other direction also, so they have just given in a different orientation. So here it is, or in the other direction, so it is like this. Right, so this is 30 degree, that means this is 30 degree in this case. Okay, so they have this is just an example of the different orientation. Right, both of the answers are correct. You may finish up to here only, so this is correct. Okay, this is, so this is the top view, and this is the front view. Okay, so step 1, this is step 1, step 2, step 3 is rotated 45 degree. So here step 3, and from here drop projectors down, and from here vertically horizontally to the right. So this is 4, and in the 5 you have to around about this edge, so you have to rotate it 30 degree. Alright, so this is the top view, and from here again you project up, vertically up, and from here you project the projectors here to the left. Alright, you form for A1 you get A1 dash and A dash here, so A1 dash you get for D1. Alright, so D1, so this is D1, so D1 will be here itself, D dash will be here itself, so this is D dash, D1 dash. Alright, so that you have to find, make sure where are the points. Right, so B dash here, so you have to make out. So visualization is also important. All right, so regular pentagonal pyramid with the sides of its base 30 mm and height 80 mm rests on an edge on the of the base. The base is tilted until its apex is 50 mm above the ground of the edge of the base on which it rests. Draw the projection of the pyramid when the edge on which it rests is parallel to the VP, and the apex of the pyramid points towards the VP. Okay. So pentagonal pyramid. Okay. So it is in this manner. So this is pentagonal pyramid. So it is like this. Okay, so this is the pyramid and this is the pentagon here. Okay, so this is the pentagon here. Base is tilted until its apex is 50 mm above the edge. Alright, so the base, so it is on one of the edge, so it is on one of the edge. So here you see so it is on one of the edge, so this is the edge and the apex is towards the VP. Right, the apex is in this manner. So the edge on which it rests is parallel to the VP. Alright, the edge on which it rests is parallel to the VP. So we have, so this is the pentagon here. Alright, so in this manner, so this is the pentagon and we have to, yeah, so this, it is in this manner. So base 30 mm and height 80 mm, it is okay. The base is tilted and its apex is 50 mm above the level of the edge. So the apex is 50 mm, alright, above, alright, and the pentagon is directed in this manner, alright, towards the VP, and it is tilted and it is resting on one of the edge. Alright, so that we have to draw. So first of all, what we draw is, so we consider that it is again standing. Alright, so it is standing here. So the pentagonal pyramid is standing in front of the VP. So that is what we are first step. So we draw this projection here, alright, and we draw the front view. Alright, so the top view we draw, so this is the top view, so we get this top view over here. So this is the pentagonal pyramid over here. Alright, so this is the step 1. So sides, base is 30 mm. Alright, so these are 30 mm, these are 30 mm, and then we project it up. Alright, and then we get the prism on top. So this is the prism which is 80 mm. Alright, then we have two apex. So this is the apex here. Alright, so this is the apex here of the pentagon. Alright, the pentagon, the apex of the pentagon. So it is at 50 mm above, oh sorry, this is the apex, okay, sorry, this is the apex and it is at 50 mm above the ground. Alright, so what we have to do is, so we have to mark this 50 mm point. So above the ground we have to mark this point. So from there we have to rotate it in this manner. Alright, we have to rotate it in this manner such that this point is 50 mm above the HP. Okay, so this is step 2. Then we drop the projectors down and the projectors in this manner and the projectors in this manner. Alright, and we get the top view. Okay, so once we get the top view, now we have to point the apex. So this apex we have to point it to the VP. Okay, we have to point it towards VP. So we will rotate this in this manner. Okay, so once we get that, again we project it up all right, and we projected this one and we get the front view. So this is the top view and this is the front view. Okay, so that is how we do. So first from this point, all right, pentagon is standing straight up. We get the pentagon. So apex is at 50 mm. So apex is 50 mm. Then we draw this projection. So now we have to point the apex to the VP. All right. So the apex is pointed to the VP, and then again we get the front view. So a pentagonal pyramid base 25 mm side axis. An edge of the base is contained by that face, making an angle 30 degree with the HP. Draw is projection. Alright, so it is straightforward. Alright, just as in case here what we have discussed. So it is, so the first step 1, we get the pyramid, we draw the front view. Alright, then we make the pyramid lie down on one of its edge as it is given. The edge of the base axis has one of its triangular faces in the VP, right? In the VP, that means. So here, here what is happening is, so the pyramid, the pyramid is in this manner. Okay, it is attached to the VP. Alright, so first of the thing is that we will consider the pyramid to be in this manner. Alright, it is standing in this manner. So we will draw the front view. The front view we will get this at the top. Alright, and the top view we will get the pyramid at the bottom. So then we will rotate it. Alright, and then this one of the triangular face of the pyramid will get attached to the VP. So that is what we are trying to achieve. Okay. So here the first step is we take the pyramid in this manner, and it is standing in this way. It is actually, in this way. Okay, so that is why the base of the pyramid, it is shown in the front view. So this is the front view and this is the top view. Alright, and then it is rotated such that one of the triangular faces, it gets attached to the VP. So it is in this manner, it gets attached to the VP. So now it is attached like this to the VP. Alright, so it is attached. So this is the front view. Alright, sorry, this is the top view. So it is rotated, it is attached. Then from here we project it up. Alright, and from here we project it to the right, and you get the front view. So this dotted edge is basically attached to the VP. Alright, so this face 1-1, O1 and 5-1, it is connected to the VP. Alright, and then we have to rotate it. So that face makes an angle of 30 degree with the HP. So this face, it is making an angle of 30 degree to the HP. Right, so this 30 degree. So once you rotate that, so you have to rotate this to 30 degree here. So once you rotate that, again project vertically down. Alright, and project horizontally to the right, and you get the top view. Okay, so this is the top view, this is the front view. So a square pyramid base 38 mm and axis 50 mm is freely suspended from one of its corners of its base. So it is actually suspended. Okay, so this corner, so here one thing you have to notice, so this is the centroid. Okay, so when it is suspended, it is at 1/4. So this is 1/4 of this height. Okay, so square pyramid, the centroid is at 1/4 of its height. So if it is suspended from this point, from that point to the centroid, it will be a vertical. All right, it will straight, because due to the gravity, it will be vertical. Okay, so when we will rotate that, as in this case, it was given that it is at 50 mm above the HP and the apex points towards the VP. So in this case also, like that, means satisfying that condition, we have to make sure that this line A dash G dash is vertical, right? And then we will rotate it in this manner. So first of all, we will draw the pyramid, alright, and about point A, we will suspend it. So as soon as it will be suspended, this will become vertical and we have to rotate it in this manner. So from there again, we will drop the verticals and horizontal projectors and we will get the top view. Now it is given when the axis makes a as a vertical plane makes an angle 45 degree. Alright, so axis as a vertical plane. Alright, so remember that. So the plane through the axis, it is making an angle of 45 degree. So that means basically the top view itself is making an angle of 45 degree. So what we have to do is we have to rotate this to 45 degree. Okay, so we have to rotate this to 45 degree here, and once so this is rotated to 45 degree here, from there again we drop the projectors up. Alright, and from here we drop the projectors horizontally to the right and we get the front view. Alright, so this is the front view and this is the top view. Okay,